This is r.d. Sharma solution class 12 chapter 19 exercise is 19.9. We are taking indefinite integrals. Now we have this sine raised 5x cos x dx. Now if you take this sine x as t, that is t equals to sine x, what are you going to get? You are going to get cos x. So dt by dx will be cos x. This dt will be cos x dx. And this dt, when it becomes cos x dx, you see what is in the second term? Cos x dx. So integration will be this sin x to the power 5, that is t raised 5. Cos x dx will be dt. Now this x raised n, when you integrate this x raised n dx, it will be x raised n plus 1 divided by n plus 1 without the integration sign. There is integration sign. So t raised 6 by 6. So this will be along with the constant of integration. T will replace by sin x now. It will be sin x to the power 6. And this is 1 by 6 plus constant of integration. This is your final result. Now this is the result, and this is how you are going to write about it. 10 raised 3 by 2 x sec square x dx. Now when you take 10x equals to t, you will directly get sec square x dx. So t will be equal to 10x that we are going to put. dt by dx will be sec square x. dx will go on the right hand side. This dt will become sec square x dx. Now we have a dt here, this one sec square x dx. So this integration will become 10 raised 3 by 2, that is t to the power 3 by 2, and sec square x dx can be directly written as dt. So t raised 3 by 2 dt it will be. So when you use the integration here, t raised 3 by 2 plus 1 divided by 3 by 2 plus 1. 3 by 2 plus 1 will be 5 by 2. 3 plus 2 by 2 is 5 by 2. So we will get t raised 5 by 2 divided by 5 by 2. 5 by 2 when it goes up, it will be 2 by 5. So this is 2 by 5, and now replace t by 10x. So 10x to the power 5 by 2 and plus constant of integration. This is your result. And how we are going to write about it? This is the way you are going to write it. Okay, 10x, if you know that the differentiation of 10x is sec square x, this will be quite easy. That's why the limit is taught first, then the differentiation, then the integration. X cube divided by x square plus 1 whole cube. Now if you remember, we have done a question for cos cube x and sin cube x. So this integration will be x cube can be written as x square into x dx. What will be the benefit of this? You will just know. X square plus 1 whole cube. Now if you put x square equals to t, dt by dx will be equal to 2x. Differentiation of x square will be 2x. This dt will be equal to x dx. If you take this 2 on the left hand side, it will be dt by 2 x dx. Integration will be, now replace x square by t wherever it is. The denominator was t plus 1 whole cube will become this one, and x dx can be transformed to dt by 2, half you can take in the front. Now what will be the next step? Because still we are caught up. T by t plus 1 whole cube, t plus 1 whole cube if you expand it, this will create more trouble in solving this kind of question. So we have to do one more substitution. So this is the first question of multiple substitution. Alright, that is t plus 1 has to be kept something so that we get t in that term. Most of the books, if you see, they will again put t. So that will not solve the issue. You have to take some other variable which is not here. For example, I am taking y. So t plus 1 equals to y is another thing. This dy by dt, when you differentiate, it will be d by dt of t and d by dt of 1. So dy will be equal to dt. So this integration I will be half of integration t plus 1 is y only, but t will be y minus 1. So you can replace t by y minus 1. In the denominator you have x square plus 1 whole cube. And if you remember, it was t plus 1 whole cube and t was taken in terms of y. So this will come. Okay, what is half will deal just now. Let's separate these two terms y by y cube and 1 by y cube dy. So y by y cube will be equal to this 1 by y square, y minus 2 will come, and that will be differentiated. 1 by y cube will be y raised minus 3 integration dy. So y raised minus 2 plus 1 divided by negative 2 plus 1 and minus y raised minus 3 plus 1 divided by negative 3 plus 1 plus constant of integration. Okay, minus 2 plus 1 will be negative 1. Negative 3 plus 1 is negative 2. So y raised minus 1 will become 1 by y. Here it is negative 3 plus 1 and minus will become plus and 2 in the denominator. So 1 by 2. Y raised minus 2, y will go in the denominator. It will be 1 by y square. This along with the constant of integration, this is integration. But y was taken as t plus 1. Y was t plus 1. First replace y by t plus 1. So negative 1 by t plus 1 plus half 1 by t plus 1 whole square plus constant of integration. Now t is x square. That is the first substitution also has to be done. So wherever you get t, replace it by x square as I am doing it in front of you. Now this half is already there outside. If you remember, I told you half I'll take just now. So this 1 by 2 will deal and we'll take 1 by x square plus 1 outside these two terms and then take the LCM, and that will be a final answer. Now let me show you this half I was talking about, and the integration will be negative 1 by x square plus 1 by twice of x square plus 1 whole square, and I'm quite sure that you'll be able to do it. Just take 1 by 1 plus x square outside. The final result will be negative 1 by 4, and the only way of doing it algebraically is I would encourage you to do this by yourself. So this is your final result plus constant of integration, of course. So how it will be done? This is the whole way you have done. So I have interpreted this question myself and solved it in a different way. You can follow some other way. 4x plus 2 into under root x square plus x plus 1 into dx. Now this x square plus x plus 1, if you take it as t is x square plus x plus 1. When you differentiate this, dt by dx will be equal to 2x plus 1. Now there is no 2x plus 1. What to do now? 4x plus 2, you can take 2 common from here. You get 2x plus 1, and this 2x plus 1, when we start integrating, this 2 you can take it outside, 2x plus 1 remains inside, under root of t will come. Not now, because otherwise 2x plus 1 has to be combined with dx, and then dt will be written. So let's do it in the second step. 2x plus 1 into dx can directly be written as dt, and under root x square plus x plus 1, because we have taken this as t, 2 is outside, 2 under root t dt. The integration of under root t is t to the power half. So you are integrating t raised half. This is dt here. It will be half plus 1, 3 by 2. 2 by 3, this goes up, it will form 4 by 3. So 4 by 3, t raised 3 by 2 plus constant of integration. And t was originally x square plus x plus 1. So when you have this, you can just add a constant of integration also with a power of 3 by 2 in the t term which we replaced. So this is how we are going to go about it. The only thing is, if you place x square plus x plus 1, 2x plus 1 will come and 2 has to be taken out. Now on the background of the question we just seen, 2x square plus 3x plus 1, this is a ditto copy of the previous one. 2x square plus 3x plus 1. If you equate it with t, dt by dx is going to give you what? 4x plus 3. I'm differentiating it. dx goes on the right hand side, so it will form dt equals to 4x plus 3 into dx. So whole numerator is going to be dt. This will become dt divided by under root of t. Under root t is t raised half. When it goes up, it will be t raised minus half. So the final result will be t raised minus half plus 1 divided by minus half plus 1. That you already know. Alright. So this is negative half plus 1 plus constant of integration divided by 2. Divided by 1 minus half is half, so 2 goes up. 2 under root t plus constant of integration. So this is 2 under root 2x square plus 3x plus 1 plus c, because I have replaced t now. So this is the result I was talking about. These previous question and this question are almost same. 1 by 1 plus under root x. Now how are we going to go about it? The first thing will come into mind is multiply 1 minus root x, 1 minus root x, numerator, denominator. Let's rationalize it. But the scenario which will be after, cannot be handled in the way we want to. So how are we going to go about it? See, we have under root x and under root x as the numerator denominator. Let's multiply this with the whole term. Numerator will be root x, denominator will be root x into 1 plus root x. Don't multiply it. Okay, if you multiply it, you will get root x into x, and that will not solve our purpose. That is why I am cancelling it. So 1 plus root x will be t, dt by dx will be equal to 1 by twice under root x. When this 2 goes up on the left, dx goes on the up on the right. So dx by under root x will be twice of dt. So this dx by under root x can be written as twice of dt. So this integration will be 2, I'm just saying that 2 can be taken outside, dt divided by what will come? T equals to 1 plus root x. How do we write root x? 1 you can take on the left hand side, so root x will be t minus 1. So this root x will be t minus 1, and this will give you t minus 1 divided by t. 2 will deal later. Let us separate these two terms, t by t minus 1 by t, and t by t of course will be only t because dt integration is t, and 1 by t is log modulus of t plus c. Now all of these will be multiplied by 2. Please remember, 2 was already there. Now multiply this whole term by 2. When you multiply this, 2 into 1 plus root x, I am replacing t by 1 plus root x now. 2 into log 1 plus root x plus constant of integration. Now, if this is the answer, no. It will be 2 root x because 2 into 1 plus root x is 2 root x into plus 2. Now, 2 root x you can keep, but this 2 will go along with the constant of integration in order to form another constant. So, 2 root x only remain from the first term. The second term will be as it is, 2 of log 1 plus root x. So, this is what I was talking about. There are different ways to do it. This is the one approach which I followed. Now this is a very straightforward question. Just a tick or trip is cos square x. If somebody knows, if it is kept as t, you will get the sin 2x as it is. When you differentiate this t taken as cos square x, it will be 2 cos x. Cos x will be minus sin x. So this 2 cos x sin x or 2 sin x cos x will be sin 2x. So this negative dt, because negative goes on the left hand side, will be sin 2x into dx, and that is exactly what is there in the numerator where there is no denominator, but still the second term you can call it as. So minus will come here, minus dt, and this sin 2x dx is negative dt, only e cos square x. Cos square x was taken as t, so e raised t, and there is only one solution for anything of e raised t integration. It will be e raised t only, e raised t. So this is negative plus constant of integration. This is not cos x, okay? I'm just writing constant of integration. So negative e raised cos square x, I'm replacing t by cos square x now. This was constant of integration. So this is your final result. Alright, negative e cos square x plus constant of integration. So this is the result I was talking about. Let on differentiating both sides, this you have to definitely write. 1 plus cos x divided by x plus sin x whole cube. Now this, if we take t as x plus sin x, dt by dx will give you whatever is in the numerator you get. 1 plus cos x, dx goes on the right hand side, and this 1 plus cos x into dx will be dt. So we can write this integration as a dt divided by x plus sin x, which is t whole cube. So t raised minus 3 it will be. When you integrate this, this is going to be t raised minus 3 plus 1 divided by negative 3 plus 1. It will be t raised negative minus 2, minus 3 plus 1 is 2 only. So minus 1 by 2, t goes in the denominator. Negative 1 by 2 t square, negative 1 by 2 t can be x plus sin x whole square. So I'm just doing it quickly because this question has already been attempted. So x plus sin x whole square plus constant of integration is your result, final result. So this is how we are going to solve it, write it. Okay, this will take in the next discussion. Till then, thank you so much and take care of yourself.